All right, we've spent a good amount of time in the past couple lessons talking about trig functions, which are sine, cosine, tangent, cosecant, secant, and cotangent. Now we are going to be talking about inverse trig functions. We have two learning goals for today. The first is to be able to find the measure of an angle when we're given one of its trig functions. So if I tell you what the sine is, being able to find the angle. That's also going to help us to find angles of depression and angles of elevation from our real world situation. So when you've got a word problem and we're looking for the angle instead of the side. So if you were asked to use your unit circle to find an angle whose cosine is 1/2, there are more than one correct answer. So if I look at my unit circle and I'm looking for a cosine of 1/2, right here I see one. So you might answer 60 degrees, so we could write that. But looking at the same unit circle, some of you might pick the radian equivalent. So some of you might say pi over 3 instead of saying 60 degrees. If I look back at it, down here, there's also a cosine of 1/2. So 300 degrees would be a valid answer, as well as its radian equivalent, which is 5 pi over 3. Now, if we went beyond the unit circle, we could find even more. We could say -60, we could say 420 degrees. All of those things would be correct answers for an angle whose cosine is 1/2. We use our inverse trig functions, which are going to be written like this. Inverse sine is how we read that, inverse cosine, inverse tangent, to find angle measures, just like we can use sine, cosine, and tangent to find missing side lengths. So there's going to be two parts in this lesson, just like there's going to be two parts when you take your quiz. There's going to be a non-calculator part and there's going to be a calculator part. Example 1 is evaluating without using a calculator. You will, on the section that has these problems, you will be allowed to use a unit circle. So feel free to refer to the unit circle that I gave you here. But it says give your answer in both radians and degrees. It also means that you need to list all of the possibilities. So not just one, all possibilities. So if I'm looking for inverse sine of radical 3 over 2, that means what is the angle whose sine is radical 3 over 2? So look at your unit circle. Remember that sine is the y-coordinate. So here is a sine of radical 3 over 2 at 60 degrees. And then I see it again over here at 120 degrees. None of the other y-coordinates have radical 3 over 2 that is positive. So it's 60 degrees and 120 degrees. So I can write those down. 60 degrees, 120 degrees, and then notice it says give your answer in both radians and degrees. So 60 degrees is pi over 3. 120 degrees is 2 pi over 3. Next one, inverse cosine of -1/2. So I'm looking for a cosine value of -1/2. So cosine is the x. I'm scanning the x's. Here's a cosine of -1/2 at 120 degrees. And here is a cosine of -1/2 at 240. So 120 and 240 both have a cosine of -1/2. Don't forget their radian equivalents. 120 degrees, we already said, is 2 pi over 3 because it's short of pi. Pi is 180, so it's pi over 3 less than a whole pi. 240 is in quadrant 3, so it's pi over 3 past pi, so 4 pi over 3. Next one, inverse tangent of 1. So that means I want to find the place where the tangent is 1. Now this is tricky because tangent isn't listed on our unit circle. You're actually going to have to use your logical reasoning skills rather than just searching and listing what you see. In order for the tangent to be 1, remember that tangent is sine divided by the cosine. If the sine divided by the cosine is going to equal 1, that means the sine and cosine have to be equal to each other. So we're looking for the place on the unit circle where the sine is equal to the cosine. So if you don't know, take a look. Where are the sine and cosine the same? Well, they're the same right here at 45 degrees. They're not the same here because one's negative. Here they're the same again. Here they're not, opposite signs. So the tangent is going to be equal to 1 in both of these places. So 45 degrees and 225 degrees. And of course they're radian equivalents, pi over 4. 225 is past pi, so 5 pi over 4 because it's bigger than 4 pi over 4. All right, next one, inverse cosine of 3. So that means that we need the cosine to be 3. Well, if you look at your unit circle, there is no place where the cosine is 3. Cosine is the x value. Notice that all of our x values are going to be between 1 and -1. So this one is really kind of like a trick question because cosine value is going to be between -1 and 1. So that means that this isn't even possible. If you punch it into your calculator, it would give you error. But this does not exist, so we say undefined here. There is no place where the cosine is going to be equal to 3. All right, last one I want you to try. So you're looking for the place where the sine is equal to 1. So inverse sine of 1, trying to find the angle or angles where the sine value is 1. So take a minute, pause it, and then come back once you think you've got your answer. Okay, so sine is the y value. So as I'm looking, here's a y value of 1. And usually there's 2 answers because there's 2 different quadrants where that happens to be true. But in this case, there's only 1 answer because down here, it's -1. So the only answer there is at 90 degrees, which is pi over 2. All right, so those are the non-calculator ones. Now, these ones you actually did back in geometry when you first learned right triangle trig. You did these kind of inverse trig functions. So all you're going to be using here is your SOHCAHTOA. So if I want to find theta right now, and I forgot to draw in these right angles, so draw those in. These are right triangles. So I've got the opposite side and I've got the hypotenuse. You should know that that means that you are going to be using sine because sine is the one that has opposite and hypotenuse. So I write my trig ratio. Sine of theta equals opposite, which is 7, over hypotenuse, which is 12. So again, I'm looking for the angle. That's why we're calling this inverse. In order to solve for the angle, you have to use the inverse sine. So when you type these ones into your calculator, you are going to do inverse sine of 7 over 12. Now, inverse sine does require a different button. You can't just press sine 7 divided by 12 equals. it's not going to give you the right answer because that's if you're looking for the side length. Here we are looking for the angle. So to get the inverse sine, you have to press the second button. So press your second button, then press your sine button, then press in 7 divided by 12, close your parenthesis, and then hit equals. Hopefully, you will get theta is approximately 35.7 degrees. So that's 3 significant digits there, 1, 2, 3. If you did not get this answer, it is possible that your calculator is in the wrong mode. Remember way back when I said that if you were going to change it to radian mode to evaluate instead of converting the radians to degrees, that you would have to be responsible for knowing when to change it. Here is one of those cases. If you didn't get this and it's not in degree mode, you need to make sure you know how to problem solve that to fix it yourself. All right, I would like for you to set up the appropriate trig ratio here to solve for theta in example 2b. So pause it for a second, try to solve this, and then come back to check your work. So in relationship to theta here, the 13 is the adjacent, the 18 is the opposite. So opposite and adjacent means I'm using tangent. So the tangent of theta equals opposite, which is 18, over adjacent, which is 13. I'm looking for the angle, so that means I need to do the inverse tangent of 18 over 13 to find my theta. So press second tangent, 18 divided by 13, close the parenthesis, press enter, and hopefully you get 54.2 degrees. Example 3, use a calculator to evaluate the expression in both radians and degrees. So this means you are going to have to switch modes. So if I want to evaluate it in degrees, let's say, since I just had my calculator in degree mode, that means I am simply going to press second sine, and then I'm going to press in that negative 0.4. Close the parenthesis and press equal. Hopefully, you get negative 23.6 if we're doing 3 significant digits, and that's in degrees. Now, it said degrees and radians, so you need to switch the modes. So hit mode, it's the third line down, change it to radian, and then press the same thing. Second, sine, negative 0.4, close parenthesis, equal. And it's going to give you a completely different answer because this answer is in radians, which is negative 0.412. So here, remember the 0 is not a significant digit, so the significant digits are 1, 2, 3, right there. So here are my 2 answers. Now, most of the time we need it in degree mode, so you may want to switch it back as soon as you finish that problem so that you don't forget, because again, you are the one responsible for knowing what mode your calculator is in. All right, so now, similar idea, we're going to solve the equation for theta, round to 3 significant digits. So notice that this time it has a restriction on our answer. It wants us to find an answer between 180 and 270 degrees. So that's interesting. So let's just see what we can do with the help of our calculator. It says round, we're going to be using the calculator here. So if the cosine of theta is negative 2/3, that means if I've got it in degree mode, that when I do second cosine of negative 2 divided by 3, close the parenthesis and press enter, that it is telling me that theta is 131.81-ish. Now, 3 significant digits would be 132 degrees. So the inverse cosine of negative 2/3 was approximately 132 degrees. But that's not the answer that I'm going to list because that is not between 180 and 270 degrees. What this is it's like we're being detectives. In order to come up with our answer, we have to pick up several clues. So the first one is that we know what its cosine is. So we use that clue to find an angle that has that cosine, which we did. We found 132. Our next clue is that the answer has to be between 180 and 270 degrees, which means we're focusing in on quadrant 3. Now, we know that there are equivalents between the quadrants. Cosine is negative in both quadrants 2 and 3. So it's not that this answer is wrong, it's just not the one we're looking for. So now I need to figure out what the equivalent angle would be in quadrant 3. And when we do equivalent angles, you have to find the reference angle. So notice I'm, not meaning to do that, but I am meaning to write this big N in red. Find the reference angle. So reference angle for a 132 degree angle, how many degrees is that? 132, 120 is 60 past, so 132 is about right here. Its reference angle is this. So if I do 180 and take away the 132, that's going to give me my reference angle, which is 48 degrees. That's my next clue. So I know now that the reference angle is 48 degrees. So now the final step is to be able to find that equivalent angle in quadrant 3. So quadrant 3, I need to go 48 degrees away from the 180. So 180 plus 48 is going to give me 228 degrees, which is my final answer. Now, I always get people who want to memorize what I did in this case. They want to say, okay, so first I subtract it from 180, then I add whatever that is to 180. No, you don't always do that. It's because those are the quadrants we were working on. What you are going to do, if your original answer isn't the answer we're looking for, is find the reference angle and then use the reference angle to find an equivalent in the quadrant you want. So you can't memorize, oh, I'm going to always subtract it from 180, because that's not always going to work. It's every case is different. Again, we're like detectives. We're just picking up the clues. So we're going to try another one here. Our first clue is that the tangent of theta is -5. So the first thing we should be able to do with that is say, well, I can take the inverse tangent of -5, and that's going to give me at least a theta that has that correct tangent. So second tangent -5, enter. And that tells me -78 points, since we're doing 3 significant digits, we'll say 0.7 degrees. So this is an angle that has that tangent. However, it's not where we need it to be. So we need to find the reference angle. So if I sketch -78.7, that's almost -80 degrees, so it's right here. And this is my reference angle, which is 78.7, because that's how far away from the x-axis that angle would be. So reference angle is 78.7 degrees. Now, I look at my other clue that it needs to be between 90 and 180 degrees. So that tells me, my detective brain says, that means I'm in quadrant 2. So if I need a 78.7 degree reference angle in quadrant 2, that means it's 78.7 degrees less than 180. So in this case, now I'm going to do 180 take away 78.7 to find the measure of that angle, which you get 101.3. Since our final answers are 3 significant digits, that just becomes 101 degrees. And there is our answer. All right, last one, and this is back to geometry again, because I know all these clues might have made your brain hurt just a little bit. So now back to geometry. You got to draw the picture, and I am not a good artist, but you should probably draw the pictures and not just draw a triangle every single time, because sometimes you need the actual picture to figure it out. So it says a crane whose end is 4 feet off the ground. Oh boy, I had to pick one that would be difficult to draw. Again, disclaimer, I am not a good artist, but I'm going to try anyway. So let's say that this is my crane. And it's on a truck, so it's got some wheels. There we go. It says its lower end is 4 feet off the ground. Okay, so that's 4 feet. And then it says it has a 100-foot arm. Would have been better if I drew this straight, but I didn't. So let's just pretend. Let's make it straight, since I don't have an eraser on my recording software here. So the arm is 100 feet. The arm has to reach the top of a building that is 80 feet high. Obviously not drawn to scale. Here's my building. And I know that the building is 80 feet. At what angle should the arm be set? Okay, that's easy enough to find. There's my angle, there's theta. So here's what I need to do. If I want to find theta, I need to make a triangle. And that triangle here would be right here. So once you've got the picture and you can visualize it, if you want to draw the triangle separate by itself, you can. But some people find it hard to visualize without. So here's the 100, here's the theta. Now here's the tricky part here. Do not put 80, because look here. This part was 4 feet. This whole thing is 80. This length is 80 minus 4, which is 76. So here's my triangle. I'm looking for my theta. So now that I've drawn the picture and not let them trick me with this 80 and this 4, now it's exactly like these ones that I had up here. So look at what you've got. In relationship to the theta, I have the opposite and the hypotenuse. So sine of theta equals 76 over 100. Since I'm looking for the angle, that means I'm going to do inverse sine of 76 over 100 to find theta. So punch it into your calculator, make sure it's into mode. And you should get 49.5 degrees for your theta. So that is the angle at which the arm should be set. And there you have it. Mathin' all day, every day.